In our last video, we explored the basic principles of working with ratios, but most ratios serve a greater purpose in an equation or problem. So in this video, we will look at how we combine and deconstruct ratios using different operations. Furthermore, while this video will use fractions, these rules will work for all ratios. We will start by adding and subtracting. Just like when we add and subtract radicals and powers, we need to have like terms. In fractions, this is determined by the denominator. Think about it. If we add 5/7 and 4/7, we get 9/7. But if we add 2/3 and 5/4, the solution is not as clear. So when we add or subtract fractions, the numerators will combine if the denominators are the same. For example, 5/6 minus 1/6 equals 4/6. Remember, because 4 and 6 are both divisible by 2, this will simplify to 2/3. But what if we want to add 1/3 and 4/5? Well, because we can create equivalent fractions, we have the ability to transform these fractions so that they have the same denominator but keep their original ratio. We call this shared denominator the least common denominator. It is the smallest number that both denominators are a factor of. Since 3 and 5 are both factors of 15, we will find the equivalent fractions with denominators of 15. 1/3 equals something over 15. Well, 3 times 5 equals 15. So if we multiply top and bottom by 5, 1/3 equals 5 over 15. To transform 4/5 to 15ths, 5 times 3 equals 15. So if we multiply numerator and denominator by 3, 4/5 equals 12/15. So using the substitution property of equality, 1/3 plus 4/5 equals 5/15 plus 12/15, which, according to the distributive property, equals the sum of 5 and 12 over 15. This evaluates to 17/15. Now that we have covered addition and subtraction, let's talk about multiplication. Remember that fractions are part-to-whole ratios where the numerator represents how many pieces you have and the denominator represents the total number of pieces possible. So when we multiply two fractions, we multiply the numerators to determine how many pieces we have and multiply the denominators to determine the total number of pieces now available. If we want to multiply 1/4 and 3/5, we would get the product of 1 and 3 over the product of 4 and 5, which simplifies to 3/20. Now we will look at division. Remember, when we talked about multiplicative inverses, we said that a times 1 over a equals a divided by a. Well, a and 1 over a are what we call reciprocals. A reciprocal is what we get when we swap the numerator and denominator in a fraction. The multiplicative inverse rule shows us that dividing by a number is equivalent to multiplying by its reciprocal. So, if we divide 1/4 by 3/5, the 1/4 will stay, the division will change to multiplication, and 3/5 will flip to become 5/3. So 1/4 divided by 3/5 equals 1/4 times 5/3, which is equal to the product of 1 and 5 divided by the product of 4 and 3, which equals 5/12. Let's see what powers do to fractions. If we have an expression like 3/4 squared, that means we have 3/4 times 3/4, which equals 3 squared over 4 squared, which simplifies to 9/16. So a fraction to a power is evaluated by distributing the power to the numerator and denominator, then evaluating. Using what we have covered in the last several videos, we will be able to tackle ratios in their various forms as we encounter them. In this video, we specifically covered operations with fractions.